Hello there. So I've written the chain rule here in three different ways, and hopefully it makes it easier for you if you are still having some trouble applying the chain rule. But let me just go over each one of these quickly. The first one here says if you have a function y and it's equal to f of g of x, a function within a function, or a function composition, then to get the derivative we start with the outside function and we get the derivative of f, but we leave the inside function the same, and then after we take that first derivative, then we multiply by the derivative of the inside function, or g prime of x. And so far in class we've gone over two different types of examples. One example is when you have a base raised to a power, and so I would say that the power is the outside function and your base is your inside function. So we take the normal power rule, we bring down the power, we keep the base, and we take away 1 from the power. And that would be it without the chain rule. But then if the base happens to be a function of x like g of x, then we multiply by the derivative, or the prime, of the inside function, in this case the base. The second type of example we've done in class is when you have a trig function and y equals the trig function of an angle. When I say trig here, it could be sine, cosine, tangent, secant, cosecant, cotangent, any one of those. And then the angle would be like g of x, a function of x. So then how do we take the derivative of that function? We start with the outside trigonometric function. So we take the derivative of that sine or cosine or secant or cosecant, but we keep the angle exactly the same. And then once we take the derivative of that outside function, then at the end we multiply by the derivative of the inside function, or here I called it angle prime. And so basically that's what the chain rule is so far in our class discussions. So here's an example, and I'll try taking the derivative. The first thing I should do though is probably rewrite this as cosine x raised to the power 1/5. And so now the derivative would be y prime equal to, I have two functions, an outside function and an inside function. So here's my inside function and here's my outside function, the 1/5. So then the derivative would be bring down the power, keep the base, take away 1 from the power, so 1/5 minus 4/5, minus 5/5 would be negative 4/5. And then by the chain rule, because the base is not x but a function of x, then times the derivative of that function, which is negative sine of x. Maybe I should use parentheses here. And then of course we just clean up the answer and try to write it as one more concise expression. So it would be negative 1/5 sine x times cosine to the negative 4/5. As you can see, I'm color coding some of the items here so you can follow rather easily. So like g of x, my angle, my base, the base here. The blue is the chain rule, and I guess it's pink, it's the outside function. So maybe try to follow it also with the colors. I'll try a second example. So example 2, I have g of x equal to the tangent of the angle 10x cubed minus 2. Anytime you see that trig function, you should immediately think of its argument here as an angle, because that's exactly what it is. So then I'm using this version of the chain rule. So I'll try the derivative by following the rule here. And so we have g prime of x equals the derivative of tangent would be secant squared. But then remember, it's secant squared of the same angle. So we still have 10x cubed minus 2. And now we say times the derivative of the angle, which happens to be 30x squared. And I guess I could use parentheses there. And so there you are. G prime of x equals, many times the 30x squared looks like a good initial factor with 30 as the coefficient, and then your trigonometric function can follow at the end. So 30x squared times secant squared 10x cubed minus 2. And again, we are following the chain rule. The derivative of the outside, secant squared, keep the angle, times the derivative of the angle. I hope you can see how that flows. Here's another example. The y equals cosecant to the fourth power of x. And sometimes students have a hard time trying to figure out, is this example similar to what I see here on this rule? So is it like a base raised to a power, or is it a trig function of an angle? Because you do have both things. You have a trig function and you have a power. But the rules ask you to do different things based on what you see. And so the thing to figure out here is the power affecting cosecant, or is cosecant affecting the power? Are you taking the cosecant of something to the fourth, or are you taking the fourth power of cosecant? And the answer is the power is affecting cosecant, and that makes the power the outside function. So if I rewrite this, we can see it clearly. This is just cosecant of x to the fourth power. And I don't really need a parentheses around the x because the angle just happens to be that 1x. And so now I'll use the chain rule, and I'll use this version of, I'll use this version of the chain rule, because now I can clearly see that I have a base raised to a power. And so it's the fourth power that affects cosecant. It's acting on cosecant. And cosecant doesn't really have much of an effect on the fourth power. So we'll have y prime equal to, bring down the power and keep the base. Cosecant x, take away 1 from the power, so power 3 now, and then by the chain rule times the derivative of the base, because the base, cosecant, happens to be a function of x, like this g of x here. Cosecant is a function of x, and so we'll take its derivative, which happens to be, do you know it now? It's negative cosecant x cotangent x. And so there we are. If you wanted to write it as a final answer, I would have y prime equals negative 4, and then I have cosecant cubed of x times another cosecant of x, so that would make it cosecant to the fourth of x times cotangent x. And that's the answer to that. So if you think back of our M&M's comparison, then the power 4, that's your shell function, and cosecant of x is your chocolate function. So you start with the outside and then multiplied by the derivative of the inside. We'll try one more example. So here we have h of x equal to cotangent x squared. And as before, people get lost and they don't know if they should use a power rule or if they should use the trig rule, because they see both. They see a trigonometric function and then they see a power 2, and things get a bit confusing. Just ask yourself, does that power 2 belong to cotangent? Is the power 2 acting on cotangent, or is cotangent acting on the power 2? Well, I see no parentheses around cotangent of x. If there were parentheses around cotangent x and 2 was outside the parentheses, then the power 2 would be acting on cotangent. But what I see is that it's just right next to the x. And so the square is only acting on x. But x is part of the angle that cotangent has an effect on. So in reality, you are taking the cotangent of x squared. And so cotangent acts upon the power 2, not the other way around. And we can make it clear by writing out h of x equals cotangent of x to the second. And when you do that in parentheses, then it's more legible that the angle is x squared. And so cotangent is the outside function, and x to the second is the angle. So we should be using this rule here. The trig is the outside function, and your angle happens to be x to the second. So we'll take the derivative, h prime of x, and that would equal, start with cotangent because it's the outside function. What's the derivative of cotangent? Cotangent rhymes with tangent. Tangent is secant squared, so cotangent is cosecant squared but negative. Negative cosecant squared of the same angle. And then you have to multiply by the chain rule, so times the derivative of the angle. Okay, so see how that works? Outside function, take the derivative of that first. Very important, keep the angle, don't change the angle, x to the second. And then at the end, multiply by the derivative of the angle to fulfill the chain rule. And the last thing we can do is clean up and say that's a negative 2x cosecant squared of x to the second. And I'm going to stop the video here, and I'll try one more video today, and it'll be when you, what do you do when you have the shell, the chocolate, and the peanut? And you'll see how some of these rules change just a little bit, but not too much. Thanks for watching.